In this video, we're going to do just a little overview of transformations using Desmos, and things I want you to think about are like how the graph is acting and why that's the case. So let's just type in some things here. I'm going to pause the video and type in some graphs. Okay, so hopefully this will work out okay and you can see good enough with this little palette here, but maybe it'll help you learn how to use Desmos too. So the first thing I did was y equals x squared, just to show you a quick parabola, just kind of reviewing. And we have our key points. I'm going to make this just a little bit smaller here. So you have the key points is 0, 0, and then you have, let's see. If we can get it on there, you can kind of touch the points or trace up and you can see exactly where they are. So that would be -1, 1, and 1, 1. A little hard showing there exactly, but let's show the keypad again. Now, if I want to reflect this and I'm affecting just the output, I would write it as a negative. I think you just put the negative in for that one, parentheses, and then I'm going to put in my function x squared and parentheses. So that's, I'm changing all my outputs to negative. And so that just kind of flips over. You can see that in the blue. So to do that mathematically, I could just write out like, take all my y values from here, anywhere I see it, like 4, I would just multiply by -1, keep the same x, and just, transfer or transform that point down, flips over the x-axis. Now let's take a look at what happens if we do the same thing, but we are affecting our input this time, which is what's inside the parentheses. Okay, so on this case, I think I need some extra parentheses in there. Let's check. Okay, so now I was real careful to get just my input in the parentheses, the negative x squared, and you can see here now my x's, if I had a 2, 4 to start with, would then be -2, 4, so it flipped over here from the original. The original is just underlaid there. You can't really see it. If I take this away, you would be able to see the original. So I'm going to take both of those away. So remember to do flips or reflections first before you do any stretching or compressing, which we'll look at next. And then those also come before shifts, which are the last thing you want to do. They have a definite order of operations because we would have issues if we did it reverse. So let's see here. Let's do one where we have, we're going to do a stretch or a compress. So we would have something like 3x squared. I need my parentheses in there. So I am multiplying the entire output that I have in parentheses is the x squared times 3, and you can see where that's going to stretch faster. So it's kind of as if you were stretching your arms up in the air, approaching the y-axis. If I was multiplying by a fraction, like just let's do 1/3, that is considered a compress. It's going slower on the increasing y values. So we're slowing it down. So 1/3 times the output of x squared. Now let's see relative what happens when we put in the 3x as the input. So I'm going to put my parentheses around the 3x and then square that whole thing. Okay, and that is in the blue. Okay, so that is even a steeper approach there. So what's happening is the X values are cutting down each time. So let me get rid of these so we can look at it relative to our original here. So if I originally started with a 1, hopefully you can see my an X equal to 1 on the, I want to get on the red. So if I originally had a 1 over here, then on my new one, the X actually shrinks down to 1/3 to get that same output. So that's kind of an interesting thing. We don't multiply the X's by 3. We actually are doing the inverse operation. So we're dividing by 3 or multiplying by 1/3. So keep that in mind anytime you have anything dealing with the or affecting the input. You're going to do the exact opposite thing, or inverse technically in this case. If we had it as 1/3, let me type that in, then you can see how it really goes out further and does not increase as steeply at all. It really slows down. So what we're doing is multiplying all the X's by 3. So if I originally had a 1 and I want to know how to transform that point, if I have 1/3 X, I would multiply my X by 3, but keep the output as 1. So that's where that ends up over here. Okay, so that's what we're talking about transforming, and you can just do it right on the graphs, on the graphs. We don't want to be plugging in points all the time. You can just at first maybe do a couple of cross checks, just plug a value in, make sure your sketch is correct. But we want to do these pretty quickly based on the parent, which is in the red here. And then we can use those points and transform them. When we get multiple steps, it gets a little tricky. If we don't have a function already told to us, like in the examples I'm going to do, you can't just plug points in and figure it out. You're just using it off the graph or kind of knowing what an idea of the function is. So that is stretching or compressing, and sometimes we're affecting the vertical versus the horizontal. So horizontal is always going to be if the input, the X, because that's our horizontal axis. And we would do the exact inverse thing. So the last one I want to look at is when we have a shift, and usually those go pretty well. Those are received nicely. So if we have X squared, our output minus 2, just the whole thing shifts down. You can see the points here for the intercepts, but basically we're just shifting down everything by 2. Likewise, if we did it as adding, we could add 2, do the same thing, and it would shift up. Every Y value goes up, the X's stay the same. Now, it's a little different if we have the input being affected though. So if I put in X minus 2 as my input, that means I'm squaring all those. So what happens here is my original actually shifted right. It's like I added 2 to all those. So in order to keep that same Y value, if it's as if I were to put a positive 2 in here for the input to get the original back, to go back to the original X of 0. So that's kind of how it works and why it's the inverse thing. You're forcing it back to its original parent value, what you would do. So that shifts right. You can see in that thicker, this one right here where I'm running my cursor along. And then the same thing if you did it the other direction and you had X plus we'll do a different one. We'll do 6, so it goes way over. I just need my parentheses and a square on there. And you can see how that actually, if I have a +6 in there, I shift left. So what I do with the X value is I do the inverse thing and go left. And you can think back, like if I were to do -6 + 6, I would get my original X value for that output Y. So that's how transformations work. Make sure you do shifts last, because as you can see, the numbers would change a lot. Like if I had suddenly now, you know, I have a -6 over here, and then if I try to multiply that, that's going to be a lot larger number than if I have the 0 that, if no matter what I multiply by, would be 0. So that's the difference there. So I will post a document as well to help you keep track of how these all work, and I hope that you found that gave you some ideas about like why these work, and help you understand what you're doing so you can remember better. All right, so that's it for the intro. Have a great day.